Consistency, availability, and the partition tolerance. These are the basic features which you are looking in a distributed system. But out of these three, only two are achievable at a particular time. And this is what CAP theorem defines. Yeah, so in this video, we'll be talking about the CAP theorem, how exactly it defines that which two factors can be used, and we will also consider a few of the example where a particular database is actually suitable for only two of the properties. So yeah, let's get started. What is consistency in terms of database? If you have a database where number of reads and writes are being done, then this consistent system or consistent database will ensure that you will always read the recently written data. You will not get any kind of stale data. So that is what consistency is. Now let's see what is availability. Availability looks more or less similar to consistency if you see what exactly I'm trying to say here. Availability actually ensures every request will get a response. Yeah, so it's look like kind of consistency, but not exactly. It says that whatever request you are sending to the system, you will get a response, but it doesn't say whether you will be getting the most recently written data or maybe the stale data. And that's where the gap between the consistency and availability. Availability just ensures that your system or the backend system is available to handle your request, but it doesn't ensure that will be getting the recently written data or not. Yeah, that is what availability is. Now let's see what is partition tolerance, which is a very important aspect of a distributed system. Partition tolerance is a property which ensures that in case of distributed system, if a particular node gets failed for some reason, your complete system is still able to handle the request. So here in our example, out of these three nodes, one of the node, which is node 2, got failed because of any error or maybe some kind of network issue. We are not able to reach that node. I hope you know that these all three nodes are syncing with each other behind the scene, because this, in case of distributed system, every data on a particular node is actually synced with other nodes also. So that's where it is also a possibility that this kind of network communication between the nodes in a distributed database can fail. So in such cases, if your system is partition tolerated, if it can tolerate the partition, then it should be able to handle the request. So this is what partition tolerance is. Now let's see all these three properties together and see how exactly CAP theorem defines. So now let's see what is CAP theorem. And as we discussed till now, it actually applies on three basic properties: consistency, availability, and the partition tolerance. Out of these three properties, only two can be available in a particular distributed system or the database. Now suppose if you are using distributed system or database, then you need to have partition tolerance at least, because that will ensure that as we discussed already, that if one of your node get failed for some reason, your system should be up and running, right? So that is what the partition tolerance ensures, that your system is always up and running for any of the network failure or any kind of issue within your distributed system. Now it is left to either of these. Now either you will get consistency out of your system or the availability in addition to partition tolerance. So the combination could be the consistency plus partition tolerance, or the availability plus partition tolerance in case of a distributed system. So that is the reason that most of the RDBMS or relational databases actually have consistency and availability as the primary focus, because those mainly use a single server database, right? Or maybe the master slave kind of pattern. But in those cases, the consistency and availability is available. I mean, it's the feature of the relational database. But if you are looking for the scalable database, right, and if you wanted to utilize the most recently scalable distributed system functionalities, then you have to go for the distributed system, and you have to have, maybe in most of the cases you have to look for the NoSQL kind of databases, and that's where the CP and AP, the combination, are mostly available in the NoSQL. Now let's see what all databases we have in these forms. So now let's consider the case where the consistency and the partition tolerance are our priority. So as per CAP theorem, we have to compromise the availability. So that means if a particular distributed system, if one of the node is down, and we have to ensure the consistency, that means whatever we have written should be available whenever we request for that particular data, then that data should be available all the time. So if that is our requirement, but one of the node is down, and by any chance that written data is on that node also, right? So that sync process between the database still is in progress, right? So that doesn't happen. So in this case, we have to stop the read request. Yeah, the system will not be available to further read because we don't want to give any stale data to the end user. So in such cases, the database system will not handle any further request for reading the data from this site, right? So this is what the consistency and the partition tolerance requirement, where we are compromising the availability. The most common example where this kind of the pattern is used are MongoDB, Redis, and the Bigtable. Consistency and partition tolerance is used in the systems where the consistency is the most critical requirement, right? So mostly the financial databases use this kind of pattern. Next combination is availability with the partition tolerance. Now in this case, we have to compromise the consistency. So again, if one of the database node is down, then the system will be available for the reads and writes. Any user can send any number of requests. The system will always be available and will handle the request and will send the data. But yeah, the data will not be the recent one. So if any of the data which has been written on the node 2 which got failed, or which couldn't sync its data with other nodes, then that data will remain there and will not be available to the end user request. So in such cases, the data given to the end user will be the stale data. But yeah, the system will be available all the time, even in case of node failure or the network failure. This type of databases are mainly used in kind of the system which require very high availability, like the e-commerce system or the ticket booking system. Right? So the example could be the DynamoDB offered by the AWS, and Cassandra and CouchDB. These are the major databases which use this kind of pattern. So the last combination, the consistency and the availability. As we already discussed, that this type of combination is only suitable in case of relational databases, and this particular combination will not be suitable for the distributed systems, because distributed systems require the partition tolerance as the must. The particular database system should be able to handle any node failure. But in such cases, where we are looking for consistency in the availability, we can have only single server databases. So the example could be the MySQL, Postgres, SQL Server. These are the traditional databases which actually have this feature, consistency and availability. So that's all about this particular session. I hope you enjoyed it. Thanks for watching. Please do like and subscribe.